Hello. Welcome. Thanks for coming. I appreciate you all attending. My name is Caleb Baker. I'm a program manager on the Windows Azure Active Directory team. I primarily work with security protocols on the STS surface. I've been working in this space for quite a while now, previously working on ADFS and Windows Identity Foundation. For the last bit, I've been really focused on this particular scenario, using OAuth with rich client applications. So I'm very excited to be here and talking about this, and I'm glad that you're here as well. First, to give a little bit of an overview of what the agenda is going to be, I'm going to start out with a bit of context setting, why I believe this is interesting, to understand how to secure mobile apps with both on-premise Active Directory and also cloud-hosted Azure Active Directory. And then I'm going to go through a practical example, writing an application using Windows Store app and the Azure Authentication Library, followed by a little bit more of a deeper protocol deep dive. And really the idea behind this is to allow you to use the protocol, see how easy it is, see how easy it would be to implement on a different platform if you wanted to extend this out. From the agenda, I hope it's clear, this is a pretty technical, developer-focused talk. Hopefully that's what you're in for. I think that was described in the abstract. But also, if you have other interests, if you want to go to a more IT pro-focused talk, I understand. I want you to use your time well. All right, so getting started, I want to talk about some of the challenges with identity, with devices, and cloud services. But first, I want to set a little context around Azure Active Directory. Who here is familiar with Azure Active Directory? Okay, so that's pretty good. So I'd say maybe a third of you. So I'll do a quick little overview of this. There was a talk yesterday, which was an intro, and I'd suggest going back, viewing that recording to get a deeper understanding. But kind of like the quick pitch on Azure Active Directory is, as the picture indicates, it's your on-premise Active Directory hosted in the cloud. And it provides a lot of the same infrastructure, gives you user accounts, access management, but there's also a re-platform involved that provides more modern protocols and management surface. But really, we view both of them as, symbiotic products, and they work better together. Now, from more of a theoretical perspective, thinking about Azure Active Directory as identity store, we really view it as an infrastructure component, just like any other Azure component, where we're providing identity as a service that allows you to securely connect people, devices, applications, which is really an extraordinarily powerful thing when you have people or groups of people and services out there, and then you can often have these isolated silos. And this pattern's repeated itself throughout the history of computers, where originally this diagram could maybe map to individual workstations, and then you get work groups, and you can go up to scales of tens of people collaborating together, and that becomes powerful. And then on-premise Active Directory scales out further, and then online you're talking about an even huger scale, where you want people crossing boundaries, being able to access all other services, and then also supporting that infrastructure for services to access other services. So the idea here is the identity platform is really creating this fabric and this mesh of identity that allows you to enable all these scenarios. Now, I realize that a lot of the times when you're out there writing an application, the first thing that you're doing isn't to write something that leverages identity, but identity is like, running water and plumbing. You take it for granted, but it's really a necessary part of most applications. And the scale that we're talking about now is just phenomenally larger if you look at the internet scale. For instance, if you go and you look at the Azure Active Directory, there's 2.9 million businesses out there right now. This is numbers that we published a couple months ago, and that might be a surprisingly large number. A large chunk of what that comes from is if anyone who has an Office 365 subscription also has Windows Azure Active Directory powering that identity system. So, and what does this number really mean? And I think it kind of depends on how you look at it. Just from like an infrastructure perspective, it's convincing number. It helps to provide, I think, some assurance in terms of the stability and maturity of the product. As part of this, we're providing billions of authentications every week. So it's a very high-scale service. And then also as a developer, I think it looks as a lot of opportunity. In those organizations are millions of people that can access your applications, either within an organization or cross-organization, or you can consume someone else's service if you wanted to outsource something and not implement it yourself. So I think there's a lot of opportunity. But in order to leverage these identities, there's also some challenges, and it's a lot of the typical trends that you're probably hearing a lot about. And mobile, people bringing their own devices to work. The explosion of devices is pretty amazing. I felt kind of silly coming out here, packing up 3 different internet connectable devices with my phone, my tablet, and my laptop. And then on the plane, I realized everyone else has the same spread across their tray. It's just phenomenal over the last 5 years what sort of explosion there's been. And then clearly the move to cloud services and also hybrid enterprise, where you want to be able to move some of your assets up into the cloud while still maintaining an on-premise experience. And these suggest several different topologies that you have to take into account. One of the most basic ones is just on-premise with Active Directory and services. And then someone's running on a device that's not domain joinable, and you still want to secure it, like on a tablet. Or you move that service into the cloud, and even if they are on a domain joined machine, and they can take advantage of integrated Kerberos authentication to authenticate to Active Directory, they still need some other protocol, some other way to authenticate up into the cloud service. And then, of course, you can move the Active Directory up into the cloud with Azure Active Directory. Or there's cases where you have hybrid, where you're going from on-premise, you have a federated on-premise Active Directory, where you can still get that integrated auth experience, but then it connects you up and single signs you on to the cloud-hosted Active Directory. And this really allows like a rich experience, but it's also a fairly complex topology when you think about it, because then you have several different identity systems that you need to talk to from your application, and you also need to talk to the cloud service. So there's many combinations that we have to look at here, and kind of my hypothesis is that we have a common approach that can solve all of these scenarios. And it's a little dramatic having it this big, but it's the only thing I had on the slide. So we're making a big bet on OAuth 2 and following the patterns in OAuth 2. And is OAuth 2 fairly familiar with people? Who's heard of OAuth 2? Okay, so a fair bit. So I'll talk about it a little bit. OAuth 2 is a recent RFC. It's been in working group. I think it's probably in for 3 years, 33 drafts. And one of the points about OAuth 2 is it's not a protocol, which is a common misperception. And I think it might sound a little bit like I'm, on a soapbox saying like, oh no, it's not really a protocol. But if you look back at the draft history, at around draft 56, they went back and they changed it. They said, okay, it's not a protocol, it's a framework. There's other language in the specification that describes it as you don't expect that it's going to produce interoperable implementations, because there's some key components missing, and that's intentional. Some of the key components that aren't there is it doesn't really describe how you're going to access a service. There's another RFC that tells you how you can do that for bearer tokens, and we'll use that later on in the demo. But it's really just a framework, which then raises the natural question of if it's just an authorization framework, what's the value that it provides? And one of the main points is I think it does provide some core patterns that people can understand. So when you do switch between different implementations, you understand those concepts, and it's valuable. It's also built on a framework that has had extensive security review. In the working group, they've produced a pretty extensive threat model. If you go just to the core specification, there's a link to it. And they thought about a lot of the issues. It doesn't make it foolproof. You definitely still need to know what you're doing when you're implementing it. But there has been a lot of thought put into it. It's also a modern protocol that works really well with HTTP services. So if you're doing any REST-based services, then it's a really good fit. It's lightweight. It is easy to implement when you're working on different platforms. In the past, we've done a lot of WS Trust or WS Star protocols and looked at, I worked on a project for a while moving WS Trust. It was like a proof of concept, putting it into Silverlight. And just repeating all of that work, trying to do the complexity of the protocol, it became daunting where you could only do some very basic profiles. Where with OAuth, and you'll see this later on, it is really pretty simple to implement. And then OAuth 2 also does provide a really good foundation for other protocol work that is happening. So OpenID Connect is going through working groups right now, and it is actually a protocol. It's defined to provide rigorous interop, and it has clear profiles. And it's all based off of the OAuth 2 framework. So this first application that I want to talk about is a Windows Store application. This is also available as a walkthrough. At the end of the talk, I'm going to have a link to the walkthrough that you can go to, and you can download, and you can do this for yourself. And the scenario that I have set up here is I'm using Windows Active Directory with ADFS that's in Windows Server 2012 R2. So this is recent support that they announced where they're going to be supporting OAuth 2 protocol. And from my to-do client application, it's a Windows Store application, I can then call my to-do list service, which is running, well, in theory it could be running up in Azure. Really, I'm just running it on my local machine here. And really what I'm going to use here to make the experience simple is the Azure Authentication Library, or AAL. You'll start seeing ADAL thrown around as well for a name as this, just to kind of clear up the confusion there. So it's really the same thing. It's been called AAL up until now, since we've just announced the support for OAuth in on-premise Active Directory with ADFS. So the scope of it has expanded from just being for Azure. And because of that, there's going to be a rebranding coming. I prefer to still call it AAL, since if you go out there and you download a package, that's the name that you're going to see if you search for any of the libraries online. And this is sort of queuing up to this point, talking about OAuth not being a protocol. AAL isn't really a protocol library. It's meant to work with Azure Active Directory and ADFS. Since OAuth 2 isn't an interoperable protocol, it's difficult to write a library that would work with all OAuth implementations. Libraries that are out there, they usually have to have some customization depending on the different providers that you're working with. And we'll get to an example, but there's one extension that we added. I think it's well justified. We try and be very cautious to deviate from anything that's in the standard. And I'll explain why we did that later. But it'll also help make clear why this library is really targeted for the Active Directory scenarios. The library that I'm using is available right now from NuGet download, and it's in developer preview. And it's specifically targeted for Windows Store. I think it's been out there for about 2 months now, and seems to have gotten quite a bit of traction. So this first bit that I want to show you here is the code that you would have to write. This is for integrated in with ADFS. And the first bit up here, sorry, I'm on the wrong machine. I can't zoom into my slides. So the first bit, the first line there, is showing setting up the authentication context. And this is pretty simple. There's just a base namespace that you can use. In this case, stscontoso100.com is the ADFS instance that's running out there. So I can point to that. And then that allows me to use that context to request an access token. The first parameter there is the identifier for the resource that I'm accessing. So I'm saying I want to get an access token for target.com. And the client ID is something that was registered with ADFS. In this case, this ADFS instance is run by someone on the ADFS team. And it's nice because I could just go and I could ask, say, this is my client ID, this is my information that I need registered. And they can go and set it up. I actually gave them the wrong information, and then I had to go and correct it, and they had to do it. So I think it was a real life, what you might experience going to your IT person and asking for an app to be registered. But really, it was pretty easy to do. And then the last bit where it's calling the service at the end there doesn't make a whole lot of use of AAL. And the reason for that is that once you get this access token back, then you can use whatever libraries you are using to access your resource. And the example here shows using the HTTP client. And in that request, you need to set the authorization header. And the keyword there is bearer. That was in the associated RFC that I mentioned to the OAuth specification. And followed in the bearer scheme, you can provide the access token. And then that will allow the resource to authenticate the caller. All right, so now I get to switch over to the demo. First, I'm just going to show you what the application looks like. And this is running that case against ADFS. The first thing that happens when the app starts up is it launches the web authentication broker. For those of you that aren't familiar with it, the web authentication broker is a component that's built into Windows 8. It allows you to launch a broker in a different process, and it provides a protected service so that the launching client application doesn't have access to what's going inside this browser. The interface to it is pretty simple. It's basically provide the web authentication broker, or WAB, as we call it, and I'll probably fall back to calling it. So you pass into the WAB a URL. It goes off and does something. And then when it hits a callback URL, it'll return that information. Now, one of the nice things about the WAB is that you can specify a special URL that's for your app that has the app package sit in it. And then it allows you to launch the WAB in an SSO mode, so you can share cookies between applications. So I have my to-do client here, and then I have another application, and they both are going to use my ADFS on-premise. Then one of them can launch it up, user signs in, it sets an SSO cookie. When the second one goes, the user doesn't have to re-authenticate. So it provides that nice separation. All right, so now I'm going to log in. Unfortunately, I'm going to have lots of password typing. And already I got it wrong. Thank you. Okay, so then it went, and under the cover, it made those calls in terms of going and acquiring a token. It called my list service, so I'm going to say, what do I want to do on my to-do list? I need to remember to buy milk. Not that exciting. Goes and calls out. The service is just running locally on the machine, so sometimes it takes a moment for it to start up. But it's making the web service call. The service is just a web API running on MVC4, and I've connected up okay, there it goes. So it calls the service, and then it's able to get that list back. And one thing I want to show here, so if I go and I close down the application, so that kills it, so I have to come back and I can restart it. The Azure Authentication Library has taken the artifact that it gained from doing that initial authentication, saved it in local storage, so that I'm not reprompted. It just automatically goes out, can access the service. If I do want to clear out that state, that's what this remove account is for here. And then in Azure, in the AAL, you can tell it to get rid of that. So the next time I'd come back and wanted to access the service, it would launch up the web authentication broker experience again. So now we can go in and look at the code. This is inside the client application. And at the start here, I have gone and I've configured my information. So here's that base tenant URL that I was talking about. My client ID is this GUID. And then I've identified my resource application with this value, which matches the physical address, which is a common best practice, because then it's easy for a caller to discover what identifier to use when calling the resource. Down here is where I've set this up, and I'm passing in the URL. I've also passed this false parameter. There's some built-in validation that can occur if you're calling Azure Active Directory, where it'll make sure that that host name is known. Since I'm calling ADFS, that's not configured in the library, so I'm saying false to turn off that validation. In that case, it's up to the client application to really make sure that it knows that this is a valid URL. Otherwise, you could be sending your user to a malicious site and have a potential phishing attack. So then farther down, I go and I make the request. I pass in that localhost app identifier, get the token back. And this is really just the code that I showed you. A little bit, the code that I showed you in the slide is a simplification, since of course you want to add some error handling. And this is all in the walkthrough if you want to look at it in more detail. But there's cases where the user can cancel out of the WAP, some other errors occurred, and then you'd want to recover from that. Here is just the call out to the service, where it calls the to-do list REST endpoint with the access token attached, and is able to receive the items, and then does a data bind to that Windows 8 Store application data grid. All right, so that's kind of the end-to-end and working with the ADFS on-premise. And now that we've talked about that, I want to talk a little bit more about the service. I've talked about how that was a Windows 8 store, or how that was a web API running on MVC4. And the main thing that API needs to do in order to work with ADFS or to work with any STS is it needs to establish a relationship so that it's able to verify the tokens that are coming from that STS and make sure that it's a trusted authority. And that usually involves getting a public key, getting the public signing certificate. And then once it gets the token, it has some basic validation it needs to do, including it needs to make sure that token's really targeted for it, and that prevents some replay attacks, where you could have a valid issue in authority, sends it off to service 1, and then service 1 turns around and calls back to service 2. So you really need to make sure that the audience inside that token is intended for your service. And you also want to make sure that the lifetime, there's timestamps in it, is a valid token. And then once you get that token, the service is validated that all the information is correctly signed. It can go in and it can get information about the user. And that's represented as claims, where the idea behind claims is just information about some entity, like a user, and that information has been asserted by some authority, in this case an STS. And then the receiver of that places whatever trust it has that feels appropriate with that authority in terms of evaluating those claims. So in this case, I'm just passing a name ID. The name identifier is a unique identifier within the tenant, and this allows you to do profile binding. So like within that application, when a user comes in, they get their to-do list, they don't get someone else's to-do list. And that's the claim that's used to do that bind. And on the service side, I've used the JSON Web Token Handler, which our team has produced. And that is for general availability now, or general availability shows that our team has kind of sucked up some of the services culture, because that's more of a services term, but really, so it's RTM, it's officially supported. You can go download and use it and run in production with it. So the obvious next step is I want to go and I want to move my service and my application to run against Azure Active Directory instead of ADFS on-premise. And you see the little pyramid has changed into a cloud. And other than that, it's the same diagram. So I'm going to go through and show the steps that are necessary for doing that. The first thing is to go to the service. And I had talked about how the service trusts the particular STS. Well, this service is coded right now to trust the ADFS STS. And how it does that is it has this hard-coded URL in it. And this points to a federation metadata document. And that document publishes issuer information, including the signing key information about the ADFS instance. So that's all contained right here, saying that I'm going to ADFS. So what I want to do is point this to Azure Active Directory instead, which is that login.windows.net. But then there's a lot of tenants that are hosted out there. So I also have to provide the name of my specific tenant that I'm running. And I've registered a custom domain name, so I have caleb.net is my tenant. So now this is going to go and point to that federation metadata document. And that's really all the changes that I need to make. Now I've pointed the service somewhere else. It's going to trust tokens that are issued from a different location. I will take a moment, though, to go through and talk about this code briefly. It talks more about client, so I'm not going to spend too much time on this, but just to give you a little bit of context if you want to go and play around with this download. So inside the web API, at the application start, I've registered a message handler. And this means for every call that's being made to a web API, it's going to invoke my custom validation token message handler. and it will run this code. The first thing it does is it makes this try retrieve token call. And this is the code that goes off, looks at the authorization header of the incoming token, sees if there is a token there, and then returns it. Otherwise, it fails with an unauthorized. Next, I go and I check to see if I have my federation metadata configured. I'll jump into this function really quick. Just to show this first part here. I'm not really retrieving the metadata on every call. Within the function, I have it cached. I have like a 24-hour cache. The reason that I do that is it is possible that the key is going to roll over. In the case of a signing key rolling over, because the STS wants to renew its key, it's going to publish multiple keys, and I want to be able to pick it up. So this is written so that it goes, it reads the metadata, gets a collection of certificates. If you look up here, it's a list of X509 security tokens that get returned. And then it'll allow any token that's signed by any of the keys that were published in that metadata. So then the service can switch from key A to key B without impacting the service at all and not causing any downtime. So I want to make sure I pick up those changes though. And 24 hours is a pretty reasonable interval. Really, I would expect the dual keys to be published for about a week before the actual rollover occurs to allow people to pick them up. But a simple HTTP call once a day seems pretty reasonable to expect. All right, so then to go back up into the code that I was looking at, after I've gotten that metadata and gotten the issuer information and the signing tokens, I can use the JWT token handler. And I pass it in these token validation parameters. This is the audience. This is what provides that check that makes sure the token is really intended for your service. In this case, it was just that localhost string. This was the issuer value that was returned, and then the signing certificates. So passing that validation into the validator along with the token, I'm able to get back, if this all passes, I'll get back a claims principal, where this is just a iClaims principal built into .NET, exposes iIdentity, and I can directly access claims from it. And I'll show how I make use of that inside my controller. So my to-do list service controller is very simple. I just have this temporary in-memory storage. But if you look at a case here, like when I'm updating new items and providing a post with a new to-do list item, I can make use of the claims principal and from current find first, and that'll give me the value of this claim. And I've identified the claim with this full name identifier value. And this value I can get from both tokens that are issued by ADFS and Azure AD. In the case of Azure AD, the values are globally unique. So across all tenants, you would have a unique value. So this is the only thing that you would have to check. You wouldn't have to make sure that both, it's from Azure AD Contoso tenant and that it's the particular value. Just looking at this value provides uniqueness across all tenants. All right, so now I've made the updates on my server side. Now I want to update my client. And it probably shouldn't be too surprising what the changes are that I need to make. It's pretty much the same thing. I'm just going to go and I'm going to repoint my client at my tenant. It's the same one, caleb.net, hosted up on Windows Azure. And that's it. Then AAL is just going to pick it up. It's going to redirect me to a different site. So I can test this, and I'm going to run these separately just to make sure the changes get picked up. All right, so it launches the application. And I'll go back and double check and make sure I didn't typo something. Aha. Login.windows.net. All right. Now I'll go through the steps for restarting. Okay, so now it'll go up and it'll send me to the logon page. It's hosted up on Azure Active Directory. You may have noticed in the previous page there was some branding that was for the Contoso ADFS site. In this case, there's no branding that I've done. You can see that this is a different web page that I've gone to. Logging into my tenant, I have my account, which is just me. Doing Caleb B at Caleb B seemed a little redundant. And it goes through the same flow, and I get the same experience. So now I can go up and register to-do items with that service. So you can see that really the change that was required just to move this over was one line on each side. It's the same protocol that's happening under the covers there. All right. So far, we went and we've shown using the AD accounts from a mobile application, and just really to emphasize, I mean, it's pretty minimal work that's required there. It was, a lot of times simplicity takes a lot of work, and in this case, I think it was true. This is a lot of work to make sure everything aligns up and is that easy to do. So I'm pretty excited with the experience that we can offer there. But of course, there's more. We still have another bit to go through. And one thing that's exciting about this approach and being able to do authentication this way, where we have like this web pop-up, is it's really easy to extend to different scenarios. And some of the scenarios that are recent is there's the device registration scenario and multi-factor authentication. Device registration is also part of ADFS in Windows Server 2000 R2, which allows you to do workplace join. How this works is you can provision a certificate to the local machine, and then from that, using that certificate, you can identify the device. So once that certificate has been provisioned to the device, and then you use this flow, it just automatically picks up that certificate over client SSL. And on the ADFS side, you can lock it down. You can say, when you're accessing this particular resource, then a user must be on a registered device that is workplace joined. So you have more control over which devices people are using when they're accessing resources in your organization. There's a talk later in the week that's dedicated to this. I have a link to it at the end of my slides here. So if you're interested in hearing more about it, I definitely encourage you to go and see that. And the point that it just works with OAuth 2. Now for the multi-factor authentication, I want to go through and show that scenario. And kind of what was fun for us internally when we were working on this, so we got the core scenario working with Azure Active Directory. The team who's working on multi-factor authentication is like right next to us within the organization. So we're like, okay, we should go over and talk to them, figure out what we need to do to get this to work. But the cool part was there really wasn't anything that we had to do. It was just you go into the web portal for Azure Active Directory, and you set an account up to require 2FA, and everything just worked since it's all right in that browser. So I skipped my demo slide there. I'll go back and I'm just going to show. So it's that same application. I'm not making any code changes. The only thing I'm going to do is I'm going to sign in with a different account. So Adam, he has rights to access high privilege things. And I can go in and enter my first factor, which is the password. And then it goes and since these are configured with two-factor authentication, and this takes advantage of active authentication, which previously was phone factor. And this goes and it allows you to register a phone to perform multi-factor auth. And there's a few options here. Really the option that I most commonly use is one that uses SMS text messages, where you get a text message, you can just type it back into it, and it performs the authentication. Since I'm in the conference center, I went with a different approach where I just wanted to go and use the OTP on phone application. I actually have a picture of it. Since I don't have my projector, I can't show my phone. So it was a picture I took in my hotel room last night. But that's basically what happens. So when I go down to my phone and open up the active authentication application, it generates a one-time password that's synchronized with the service. So then I can go back here and I can type in, currently I have 994090 and sign in. So then the server goes and it verifies that that is actually in sync with the device that's registered for this user. And it just changed on my phone. So, okay, cool. It was still in the timing window. So now I'm in with two-factor auth. And after that, everything works the same. Client application logic's the same. Service logic is the same. So you can see how you get a lot of power on being able to add on these different scenarios as more becomes available at the service. All right, so now this next part goes a little bit deeper into the core of the protocol and what's really happening under the covers. General advice is still use a library when it's possible, when it's available on the platform that you're doing. It's harder to implement the library than it seems. A lot of my premise here is that it's simple, but you can still make little mistakes, or even if they're not security issues, there can be usability issues. But in some cases, you can't use the library, primarily if there's not one available. And right now, the available libraries are limited just to the Windows Store applications and the AAL.NET. But more coming. We definitely view it as a high priority to target the more popular mobile platforms. I think it's probably pretty obvious what those ones would be and what we're working on right now. But until that time, it's good to know how things work under the covers. And I also just think it's really valuable, even if you do have a library, things happen. You're going to see, an error as you're developing the application. And I find it useful to have a deeper understanding of what's going on under the covers to help diagnose some of those cases. So what I'm going to walk through here is just looking at some of the logic to a really simple test client application that I've written. And the purpose of this is just to illustrate the protocol flow. It's doing basically the same thing that the Windows Store app did, but it doesn't use any version of AAL. It's just all hand-coded. For this particular flow, and the same thing that we showed in AAL, we're using a specific profile of OAuth 2, which is an authorization code profile. One of the advantages to this is that when you use the authorization code flow, you also get back a refresh token, and that refresh token can be long-lived and used to request more access tokens. And that was that artifact that I mentioned that was being cached by AAL that allowed the service or the application to start back up again and still have access to the service. And right now, this protocol support is in developer preview on Azure Active Directory, so you can go out and try this out now. Just going to do a quick swim lane diagram of what happens here. On the left, I have my device with the application that then calls out to the browser. Like in the Windows Store application case, that is the WAB. And then at the STS, there's two endpoints. One's the authorization endpoint, which is that endpoint that the user sees, that they log on to, that they can provide consent. And then there's also an active endpoint that's used for redeeming the code that comes back and for acquiring a refresh token and access token. And then the access token can be used to call into the resource. So going through this, so the app goes, requests that code. The code launches up the browser, which navigates over to the authorization endpoint. User authenticates, code gets returned to the application. The app is then able to go and make that direct request for a token. And this is just straight app to token endpoint, and go and access the resource. The token request pattern can be repeated using that refresh token for the lifetime of the refresh token. And currently what we have is a 60-day lifetime for that refresh token. This is an area that we're looking into quite a bit right now in terms of what sort of policies we want to have with that refresh token. Some that we have in place right now is the refresh token is attached to a particular user. So we're able to look up in Azure Active Directory to see if that user is still in a valid state, if they've been disabled or deleted, and in that case not send out new access tokens. So they don't have extended access for that application on behalf of a user. All right, so now I'm going to switch back over to my desktop and launch up my test client application. I'll close down this one so it doesn't get in the way. And just to give you a quick view. So I have like just the skeleton. Well, I have quite a bit underneath, but there's things that we need to go through and enable. The idea is to go through and demonstrate the different parts of the flows. So pretty much in each of those hops of getting the auth code, getting the access token, using the refresh token, we'll light up the protocol flows over here. On the right is the viewing window, where like when I need to show a web browser, I'll show it over there. Also, when I want to show like the full responses that I'm getting back, I'll show it on that side. However, I don't have an application that's registered right now, so I need to fill in all this information. So I'm going to go to the Graph Explorer. And I should say something about this in the Graph Explorer real quick. This is just part of the developer preview that we're leveraging this tool. There's work being done to actually integrate into Azure Portal. And I don't know how many of you have seen the Active Directory portion of the Azure Portal. But if you go down here to the Active Directory sign, go into my account, those are my users. There's Adam and my main account that I was using. Like in the case of Adam, you can go in and you can see that he does have multi-factor authentication enabled. And I go back up. And this is where you would register applications. So to light up like this to-do client type scenario, you would need to register an application for the client and then also for the service. There's just one registration for the client. It's not across all installs of the client. I debated about whether to show some work that we have in prototype, because we're pretty far along in how we're going to integrate this scenario in, or to show you the Graph Explorer route. And I decided to do the Graph Explorer since this is something you can actually go out and do today. So you'd go to graphexplorer.cloudapp.net, and I also have that link at the end of the slides. And you can sign in with a particular user. So I'll go and sign in up there. I get redirected. I'm going to sign in as my tenant administrator. All right, so now when I'm signed in, I can go and I can use the Graph Explorer. It queries the OData feed that comes from the graph, where this is a OData feed that gives you all the contents of your directory. It's pretty nice to program against. But then also there's the addition of this link, which is add application permission. So this is what I need to go and do. And the reason it's called add application permission is what I'm actually doing here is, so I create both my client and my service, and these are application objects inside the directory, but then I also need to create a relationship between them. So I, as an administrator, can say, this client application is allowed to call this specific service. And that's an explicit intentional action that I do. It's not that any client application can call any service. And then as part of that, I can also say some representation of the permissions that I want encoded inside of that token. So the first thing I'm going to do is how this UI is structured. I could select previously registered services on this side, but instead I want to go in and I want to create a brand new client application and a brand new service. So I'm just going to do demo client, and that's just a display name. It doesn't really matter what the value is. This next one is the return address for the client application. This is the address that when the authorization endpoint is done authenticating the user and ready to issue the code, that it's going to send that code back for the client application to capture it. It doesn't really have to be a physical endpoint. It's just some endpoint that the app needs to know about and that can watch for in order to monitor and get the response back. And we'll look deeper in how that's used when we work on the client app. So I have my demo service, and then this is the identifier for the service, which would be probably a value that maps to the physical endpoint of that service account. So let's do demo. Just making this up since it doesn't really map to anything. And down here, I can specify what permission I want. The default is just saying user impersonation, and the intent of that is that that client application can have full rights that user could at that service. But say I want to limit this and I just want to give them read rights. So then this will be imprinted inside the token. So then the service could go, whatever the service is, could go and see, okay, this client application only has reads. I'm going to scope down what those permissions are from what the user has. Underneath that, you can see that the default here is to check that it's a public client. That's not a term that we're going to use in the official UI. It's leaked in. It's from the OAuth specification, where public client means any client that's unable to keep its own secret. So that's like a mobile application, since and there's cases of this where people go and they hard code a secret within the app and then they deploy it. And of course, that's not really very secret, and any security built around that assumption is flawed. So by marking this as a public client, it means that you're not assuming that there's any secret that's being kept, so there's no authentication credential. It really all relies on the fact that the user's gone through and consented, and they're running a trusted application on their machine. All right, so now I've gone through and I've configured all of this. So I'll create my permission, and this goes back and it creates the objects and gives me my information back. Now I can just copy this over to my test client. So I have my client ID, which is this GUID that was assigned to me. So I'm going to set that. And then my app URL for my client. This is my client redirect URL. And then my resource identifier. All right, so now my test client's configured to run against these objects that I've just created. Now, the first thing that I do when my application starts up is I'm just going to form the basic request to call out and get that authorization code. And that's what this little bit does in the Windows load. So on the URL for the authorization endpoint, I go and I format a few query parameters. The first one is the response type. Response type in OAuth 2 is just indicating the answer that I want to this request, and I want to get back an authorization code that I can go and redeem for an access token, so response type is code. As a client application, it needs to identify itself, so it passes the client ID as the next parameter. The redirect URI is actually optional. If you only have one registered, you can omit it. Best practice, though, is I would recommend including it, because if in the future you go and someone updates that application object and has multiple redirect URIs, then it becomes not as deterministic where the response is going to be returned to. So if you have a client app that assumes it's going to be returned to a more specific location, and someone goes and adds another URI, your client app could start breaking. So I recommend doing that. And then resource, this identifies the target where you want the token for. And so the resource parameter, I had mentioned earlier that we had done an extension in the OAuth 2 protocol. And this is the extension. The resource parameter, it's legal to extend the framework, but this resource parameter doesn't exist inside the OAuth 2 specification. And the reason for that is the main scenarios that OAuth 2 was developed around were cases where an authorization server is really tightly coupled to the resource. So you can imagine, just taking Facebook as an example. When you go and you authorize, all you're doing is you're authorizing access to a Facebook Graph API. The resource is implied by the fact that you're going to the Facebook authorization endpoint. And this is true for other providers as well. But what we wanted to do is we wanted to extend it out and make it so ISV developers could go and register their own resources, and Azure AD could act as the authorization server for those resources. So to create that decoupling, we had to introduce this parameter so that you could say that it was going to go into a particular resource. There's another proposal for doing this, which would be that you could pass it through a scope parameter, where scope is intended to identify which permissions were going to be within inside that token. And the reason we didn't go that route is for a particular resource, you can define a custom set of scopes. So like when I'm going to the to-do service, it can have, read to-do, write to-dos, and I don't want those scopes to overlap with how they're defined on some other resource endpoint. So we've introduced this resource as a separate parameter. All right, so I'm just going to comment out this line. All this does is it goes and fills in that text box, shows this request, which is just this URL with query parameters attached to it. And then there's that button for going and launching the request. And all it does is it invokes the web browser that's hidden, so it makes it visible, and passes in that URL to navigate to it. The other important part is to add this event handler so that it goes and monitors the navigations. And within that web handler, what I'm doing is I'm watching, since I've registered that client redirect URI, and I know that when I get the web browser going back to that redirect URI, that the transaction's completed. So I just watch on every navigation, see if it hits that URI, and once it does, I scrape the URL, pull off the code query parameter, and return the value and show that in the application. So I can show that working now, where I'll go through. This is my request up here. Hit go. And then over on this side, it renders the web UI. So this is just what you saw in the web authentication broker. I'll sign in. And you can see the response. This is just showing the query parameter where it's code with the value. And it gives me the authorization code over here. All right, so I finished that first leg, the first transaction, going over to the authorization server through the web browser. I'm going to save this authorization code since it has a 10-minute lifetime associated with it. So now I'll just be able to manually plug that in later to save me from typing in the password again. All right, so this next bit that we want to do is take that authorization code, use it to talk to the token issuance endpoint, and get back the token that we're going to use for calling the service. And the way that I'm doing that is I just watch for that authorization code text box to have a value change, and then I format a request. Well, let me do that again to get that out of the way. All right. So inside this request, this is going to be a forms URL encoded post to the token issuance endpoint. Pretty simple semantic to it. So the first parameter is the grant type, and this identifies that I have received an authorization grant. In different OAuth profiles, there's different authorization grants that you can receive. But in this case, the grant type is the authorization code that I returned, and I pass that up. I have to provide the redirect URI that was used. This is mandated by the OAuth specification, where if you provided a redirect URI in the initial request, you also provide it during the token issuance request. And this is just to create an additional binding between the authorization request and the token request. And then again, the client ID, and then of course that code value that I was given from the first interaction. So this will just write all of that into the text box. So I'll go through and do that. I have my authorization code cached away here. Go and create that post, and then I get a response back. We can take a quick look at what I get there. So this is just a JSON object that I get back. The first property is the access token that I'll use to go and call the service. Then there's properties, there's token type, where this is just indicating the semantics around the token. So it doesn't actually tell you the format of it. Like it doesn't tell you if it's a SAML token, or in this case, it's really a JWT token, which we'll talk about a bit more later. It's just saying the usage of it. So it's a bearer token, which means the client doesn't really have to do anything special. It can just take it, stick it in the authorization header, and play it. There's other token types, which are holder of key, or you have to do some crypto on the client. So it's important to watch that value and make sure that you're, don't have an unexpected token type. Below that is information about when the token expires. There's two ways this is represented. Expires in is just the number of seconds, and that can be useful if you're on a machine where you think that your time skew is off, so you know this token's good for an hour. Or then there's expire on, which is epoch time, which would give you an exact time that it expires. And then below that is the refresh token. And then finally on that last line is a representation of the scope. Scope's also in the token, but this is just for the client. It's kind of information for the client saying, yes, this permission was actually issued as part of this token. And then over here, I've stripped out the refresh token. So I'll copy that off so I can use it again. The nice thing about this, too, is you can kind of play around with it. So like if I go up here and I update the authorization code, so of course, so I've deleted a bunch of characters, it's invalid. I can replay the request, and you can just kind of play around with it and see what happens. So in this case, the code was the grant, so the grant was invalid. And it's a nice way to kind of like poke at the system and learn about how it works. So the last little bit that we need to do is wire up the refresh token request. And that's the easiest of all of them. At this point, you've already done any of the binding, that you know that what client you're using, you know that you use the right redirect URI. So the only thing that's required to do is to pass up the grant type. Now it's a refresh token instead of an authorization code. And then to actually pass up that refresh token value itself. And that's just the simple post that's involved. And then that will go and return you the same response that you receive with the authorization code. So I can just show that really quickly. So this is my old refresh token. Post it down here. I can play it against the server. I can keep playing against the server. And like I said, that currently has a 60-day lifetime in it. So that's what you'd want to cache long-term within your client application. So hopefully that shows a pretty good overview of what's going on. Like I said, it's pretty straightforward. Some of the things that when you're writing, if you are doing your own library, that you want to think about are like the expiration times. You want to do your own caching logic. You want to be able to handle errors correctly so that if an access token has expired, that you go and you refresh it at the right time. All right, so now that we've talked about the on-the-wire protocol, I had mentioned that we were using the JOT or JSON Web Tokens. JOT is like the pronunciation called out in the specification. It's a commonly used format. It's currently going through standardization. It's not fully ratified yet, but it's been very stable for quite a while now. And it's really a core component in OpenID Connect. I had mentioned that OpenID Connect is an interoperable protocol that's being worked on, and the JOT token is one of the things that make that possible. In all of the OAuth specification, there's no token types. There's no definition of that. So JOT fills an important hole. And it's just a very basic JSON serialization. And I can show you what it looks like. I'll switch back over here. So inside this response, I've gotten back a JOT token. And the format of this, it's in 3 segments. It's base64 URL encoded. There's a header, body, and then a signature at the end of it. I have this very, very rudimentary site which doesn't do any signature validation, but it'll take it and it'll do the decoding and return it in JSON. So once you base64 decode it, you can see here this is the header, and it's telling me that the content type here is a JOT token. And there's it's RS-256 that was used for doing the signing, and then there's a certificate thumbprint. So if on my service side I wanted to look up the right certificate to do the validation of this token with, I could use that as a hint. And then in the main body is where the claims information is. This is the audience. And this is the value that tells you who the token's intended for. That needs to be verified by the service. Issuer, who issued the service, not before and expires for expiration information. And then there's information about the identity of the user. So there's the object ID. Object ID is not inside the ADFS tokens. It's only inside the Azure Active Directory tokens. This is the immutable unique identifier for a user account in Azure Active Directory. So if you were going to turn around and use this identity to query the directory graph, this would be the recommended value to use. It's kind of like the equivalent of a SID for the online services. The tenant ID is the unique identifier for that tenant. And UPN, I think, is pretty straightforward. Sub is actually the claim that we were seeing represent his name identifier. There's a parallel between it and the name identifier that's inside a SAML token. The Azure Authentication Library was just doing normalization. So that at that point in the code where I showed like the full URL and doing the query on that, that wasn't an actual match of what was inside the token. It just does a mapping. So that if that service received a SAML token instead of a JWT token, none of that code would have to change. And for some of these token types, okay, that was my decoding. So these are the mappings. So the sub goes to the name ID. The object identifier has long formats. And that's how they're all represented, which is kind of handy. It's useful if you're debugging any of this and you want to understand what's inside. So what we've gone through, I mean, so I think there is a lot of opportunity here. It's really powerful using both the on-premise AAD and Azure Active Directory for securing the mobile applications. And I think there's a good developer experience around doing that, and it's going to continue to get better. I'm looking forward to having more platforms supported, and the simplicity of it also helps us in terms of being able to do that more quickly. There's some associated sessions that I'd recommend checking out. That top one, the Secure Access Anywhere, is the one that's related to the device registration that I had mentioned. And following that is securing online cloud applications, where this is line of business applications, which will tell you if you want to write an app that can be used by those 2.9 million other organizations, and then you can provide that as a service to them. That's a great talk to go to learn more about that. The following talk is going to talk to you about the graph if you want to learn more about making those REST API calls, followed by a talk telling you how to connect up that on-premise AD infrastructure to Azure AD Online. Here's some links, just various things that I talked about throughout the talk. There's the links to Azure AD, a couple blog posts. There's the blog post that talks about that 2.9 million organization number, which goes into more detail about some of that usage. And then the links to the Graph Explorer. The last link isn't live yet, so this is my own. I don't know, how commonly uses GitHub? Like, who here uses GitHub? Okay, so reasonably. I have to admit that I am aware of it, but I haven't really used it very much. So now my project, after I'm done with this talk, is to go and publish that test client application code that I have. I've started my repository, so I have the URL for it, and that's where I'm going to put it. I've also just put all the links up. Those links that I just showed are available there as well, if you just wanted to get that before the slide deck is going to be present. And that is the end of, if anyone has any questions, I'd be happy to take those. Yeah. I'm sorry, I can't quite hear. Okay, so the question is for the on-premise scenario, is ADFS required, and what version of ADFS? So for what I've shown with the OAuth support, that's the Windows Server 2012 R2 is what's required. That's where the OAuth support comes into play. All right. Any other questions? Yeah. Okay, so the question is, do I think that ADFS will be replaced by Windows Azure Active Directory? I think it's going to be a long time that there's going to be on-premise infrastructure. I mean, as long as there's hybrid enterprise, which to me is the foreseeable future, I expect ADFS to be around. So if the talk at all is like more focused on Azure Active Directory, all I would take away from that is I work on the Azure Active Directory team. I'm just familiar with ADFS. Right. So the point is, so that if you connect up and have on-premise syncing to the online infrastructure, that's true. Some of the benefits that are really hard to move up to the cloud is like that integrated auth scenario or that Windows auth. So if you have your client application, you still want to, you just want to log on to the desktop. You want to be able to hit with integrated auth ADFS on-premise and get a token that federates you straight up to the cloud. So I think it's going to be core for that scenario. Yeah. Okay, so the question is, if I understand correctly, just basically questioning about the authorization model. In this case, what I've shown is like pretty simple authorization, where there's just scope, it's just saying read. I mean, you can expand that out to n number of values, but clearly like the power of groups or roles is still useful. And that's something that you can go through, like when you get that object identifier back in your application, that would be like a perfect use case for calling into the graph. You could go and you could find out and do a rich query and find out which groups that user is part of. And it's also an area that in the future I think we're going to continue to invest in to also make it more streamlined. Because in some cases, people don't want to have that extra service call out. Yep. Any other questions? All right, well, thanks again for attending. Please do the session evaluation. I hope that it looks interesting, that it looks, doable, particularly like that test client application. Really the steps that I showed there. Once you have an Azure subscription, that's all you have to do is go into the Graph Explorer and you can run through and play it. So I'd really encourage anyone who's interested to go and at least try that part out and get a feel for the experience. And also feel free to contact me. I'll be in the booth on the floor later on today too, if anyone has any further questions. And again, just thank you. I appreciate you for attending.